Very good morning. Yesterday we were discussing about the control charts. In fact, we are talking about the quality characteristics and what are statistics and what is meant by X bar or what is meant by central tendency and what is variance or variation, like that. And why do the variation occur? Why does this variation occur? And the main emphasis of this control chart is on controlling this variation as well as the average. That is what we came to know. That means first we need to calculate the average value and the variance. And we identified that the X bar arithmetic mean is the best measure of central tendency. That means we said arithmetic mean is the best measure of central tendency. And how the spread or the dispersion is measured. That is what also we discussed. We identified that the spread or the dispersion can be measured by several things. One of them was mean deviation, that is the deviation from the arithmetic mean value, or maybe it is mode or median, whatever it is. But since we have taken the arithmetic mean as the measurement of central tendency, that deviation, whatever is there, the deviation has to be from that arithmetic mean. So we talked about mean deviation, it will give the spread, but when we took the deviation from the value, that average value, and then mean of those deviations, it is the characteristics of the arithmetic mean that this will become, mean deviation will always become 0. That is what we have seen. That means that is what I have showed it to you. Then second, they thought, instead of taking mean deviation, mean absolute deviation, mean absolute deviation, which is called in short by MAD. That means you take the same deviation, instead of taking the mean of those deviation, you take the absolute values and then the mean of those absolute values. Okay, the problem is what? It gives the result, but it cannot be subjected to further mathematical treatment. Why I will say? So let us take an example. Say for example, I have got three values, 3, 4, 5. If I find the arithmetic mean, the arithmetic mean is going to be, or if you say this is equal to 4, and 3 plus 4 plus 5 divided by 3, it is going to be 4. Arithmetic mean is 4. So now if I try to find out the deviation from this mean, that means 3 minus 4 plus 4 minus 4 plus 5 minus 4. And its mean value, there are three values, so divided by 3. What is that it is going to give? This is going to give minus 1, this will be 0, this is plus 1 divided by 3, this tends to 0. This is going to be 0 only. That is what I told you. This is the property of this arithmetical mean. And this is the case I cannot use. Then somebody suggested, instead of taking just these values, you take the absolute values. These are the absolute values and their mean. That means what it will become? 3 minus 4, its absolute value, I am going to consider it as plus 1. This is 0 and already it is plus. So this will become 2 by 3. Yes, it gives some value, that is 2 by 3. Okay, fine. But the moment I take it as the absolute value, it loses its direction. Only we are talking about the magnitude then. No longer the vector quantities can be handled in this way. But most of the things we want in which direction it is moving and other things are required. So we need to treat the vector also. That is why they said that it cannot be subjected for further mathematical treatment. That means whether the value are increasing or decreasing and other things may not be possible. Because this plus or minus whatever are there, they will denote maybe it is clockwise, anti-clockwise, increasing, decreasing, or the tensile force, compression force, magnetized, not magnetized, like that. Then they started thinking some other thing. That they said, instead of doing like this, just taking the absolute this thing, let us square it. That is what they started thinking. That means 3 minus 4, you take same values, I am taking 3, 4, 5. See how we are playing around. This is what, that's the beauty of the statistics. 3 minus 4, earlier I took only 3 minus 4. Then I took the modulus of that. Now what I am trying to do? I am trying to do plus 4 minus 4. And then you take its mean value. Mean value is, its mean is how much? Because whatever the values are here, if it is squared, always it will become positive. Because 3 minus 4, it is minus 1. But when it is squared, it will become plus 1. Same is true. Because if it is negative, it will become positive. If it is positive, it will remain positive. So I am going to get that one. So here, there is no loss of this sign and other things. Everything is considered. Hence, it can be subjected for further mathematical treatment. This value is called as the variance. In general, what we have found out is, this is the variance. Individual value, you take it, square them, then take their mean. This is called variance. But what is the problem with this? Suppose if I say, these are 3, 4, 5. What are these things? Let me say that these 3, 4, 5 are some time taken for completion of a particular job. Maybe in minutes, let us say. If we time it, okay, some has taken 3 minutes, 4 minutes, 5 minutes. Okay, that means it is the time taken. What are the units? Minutes. Okay. The moment I find out this one, if I square it, what is that is going to happen? This will become, its unit will become minute square, which will be meaningless. Instead of this one, maybe 3, 4, 5, if I take every minute or whatever it is, so much rupees he is earning, let us say, per minute or per hour, whatever, let us not bother much about it, small amount or more amount. Let us say that if it is the rupees, they are rupees, expressed in rupees, then when it is squared, it will become rupees square. What are the units of the variance? Rupees square, which will become meaningless. So the unit compatibility is lost. Then how to take care under such circumstances? And somebody suggested, okay, you take like this, then to have the compatibility about the units, you take the square root of this. Okay, that means if I take the square root of this, so the minutes, when I take the units will become minutes or rupees, whatever it is. So everything is compatible. This they called it as the standard deviation. Is it understood? Or in other way, this standard deviation is nothing but RMS value, RMS value. You can state, it is very easy to remember these things, calculation, because it is most important now. Because you need to calculate. When we are going towards the construction of control charts and other things, we need to find out these deviations or these standard deviations or variance or whatever it is. In that case, we should understand what is meant by this. So RMS, the standard deviation is nothing but RMS value. RMS means what? R root M mean S square. This is nothing but root mean square value. You just observe here. You can square. We have taken the square. Square of what? Deviation from with respect to the mean value. So we have taken, we have made it as the square. Then we have taken the square root of that. Roots mean square value. Okay. So this is nothing but standard deviation. So any statistics or any samples or any information, statistical information, as I told you, it will be collected in the form of numbers. And they can be expressed like this. Say they will be following a particular, because they will become the part of the collected information or data, and they will always follow some frequency distribution. Some distributions they are going to follow. Okay. Usually we'll be making use of two types of distributions. One is continuous distribution, another one is discrete distributions. Try to understand. One is continuous, another one is discrete or in the steps. So it will not take in between values, because when we are talking about this control charts and other things, or when we talk about statistics, it becomes inevitable for us that we must be strong in understanding what is probability, what is frequency distribution, because probability is again related to the frequency distribution. It is nothing but relative frequency. Probability is what? It is relative frequency. So ultimately we will end up with that. That means this all management decisions or whatever it is we are going to talk about, we need to have the sound knowledge about the probabilities. That is why, or some basic knowledge about the statistics. That is why I am spending some time for this one, or it is a sort of revision. Because without this, this is a prerequisite. In fact, this is a prerequisite for these units, these 3 units, that is third, fourth and fifth units. Prerequisite is probability as well as statistics. And statistics, in the sense, we have to find out if we have to express it in terms of some frequency distribution. We know that it will have some mean value and it will have some dispersion or the standard deviation, and how it is to be found out. That is what we were discussing. We can understand that. You try to understand. These things were developed when nothing was known about the computers, and even the mechanical adding devices were just started, because these things they started evolving. That is what I told you. The Sheward, he was the pioneer in developing these control charts way back in 1920s. That time only the mechanical adding machines were there and computers were not there. So finding the large values and other things were the problematic thing itself. Nowadays it doesn't make any difference. You can use anything. Okay, that you try to understand under what difficult time these things were produced. Now if we apply, fine, no problem. Any values you can give, I can They develop the algorithm for that one, and immediately it will give me the results. Earlier it was not so. So then they started thinking, is it possible to, instead of standard deviation, finding the standard deviation and other things, which is such a long thing, is it possible with a simpler thing so that we can estimate about the parameters of the population or the universe? Okay, my friends, you try to understand here. I am again bringing in some new words, new terminologies. One is population, or the universe. Another one is statistic. Statistic is concerned with the sample. Because this is a subset of the population or the universe. Sample is a subset of population or universe. Try to understand. See here, so you know what that means? We are going to manufacture some lakhs of some unit like this, lakhs. Then whether it is meeting the particular standard or not, if I go on measuring each and every element of this 1 lakh units, I don't know how much time it is going to take up. So instead of that one, what I decide, I'll just take a sample out of it. It is just like finding out whether the rice is cooked or not. We are not going to test the entire thing. We will take only a small part of it. And based on it, we are going to decide whether the rice is cooked or not. Likewise, the same thing is true. That whatever small thing we have taken, that is called as a sample. Because the thing about this one, it is called as the sample. Same thing. That means it should represent this entire universe. That is what is the crux. That is called as the statistic or the sample. That means this is part of the entire universe or the subset of universe or population. Because this universe or population, it has also got the variation. It has also got the central tendency. Those are represented because this is the universal thing. That is what I am telling. The universal mean or the population mean is represented by x bar prime. Whenever the prime thing is there, it represents or it is concerned with the universe or the population. In subsequent studies, we are going to use that. Similarly, universe standard deviation is represented by, because standard deviation is represented by sigma, so the standard deviation of the universe or the population is represented by sigma prime. If I just mention sigma, sometimes what we do is instead of x bar prime, we'll use mu prime. It is widely used. Instead of x bar prime, we use mu prime. Both are same. That is the mean of the universe, mu prime. Or x bar prime is mu of the universe. That means universal average. And sigma prime is standard deviation of the universe or the population. Okay, these two things are required. Okay, this is what we have understood. Now, what is that we are trying to do? I want to take a small sample out of the universe, because when the process is going on, then only we can correct it. If after process is completed, if we are going to test it whether it is done or not, then it is of no use. So friends, the controlling thing when it comes, you just try to understand. There are three phases of any of the activities. One is the activity itself. Other thing is before the activity what is to be done, or the work will consist of number of activities, okay? And this is after work. Before work, about that particular work, whatever we do, it is called. And after the completion of the work, there is nothing else. There is going to be only the effect. Okay? Only that one is there. Whether that's all. We cannot correct it. But when the work is going on or when the process is going on, then the controlling comes into picture. Then whether I can test it, I can check it, whether it is going as per or in that case I can take the corrective action. Again I can bring it back to on the proper track. This is what is done in control charts. That is what it is controlling. Controlling that particular process itself. I am trying to give you, or we can ourselves we can frame what are going to be the objectives of this control chart. That is what I am going to reach. Okay, this is what it explains about that one. That means once the process is in the work is under the process, then only the controlling will come into picture. Otherwise it will not come into picture at all. There is no point. Okay. So whether it is going to manufacture some 1,000 parts or 1 lakh parts, after 1 lakh or 1,000 parts are manufactured, if I find out that there are so many mistakes, I cannot do anything. I cannot rectify it. At the most, I can say that the good items or pieces only will reach the customer. That is what I can do. Nothing more. I cannot correct it. But if I am able to find out, no, if there is going to be something wrong, then I can correct it. So I can take the initiation that at the first hand itself that all the 1,000 parts manufactured will be good. That is what way this control chart, it helps us whether the things are going as intended or is there any deviation. Why deviation? Because earlier we said in nature the variation is inevitable. We cannot do anything about it. Variation is inevitable. But how much variation is tolerated? Yes, that we can fix. How much variation is allowed? Yes, we can think about it. And we can fix those levels. And if sometimes if we observe that it is exceeding those variations, then I can say that yes, there must be some cause, some assignable reasons. That is why it is exceeding the spread of the intended thing. Then we can stop the process and then try to investigate. That is the crux of these control charts. Whether they are control charts for variables or control charts for attributes. Okay? So in the sense, what we'll do, we'll go on taping as the predetermined time or some random way, we'll go on collecting the samples. Okay? Then based on the samples, we can go on drawing the conclusions. What conclusions we'll draw? Based on these samples, we are going to draw the conclusion about the universe or the population. Because I don't know these values really. I can estimate them by taking the samples. Try to understand. From subset values, I am going to find out these things. Okay, that is the beauty of this one. What this one? This is what is important. So from the sample statistics, I am going to estimate the population parameters of the population itself. Otherwise, which could be measured after the work is completed, then it is of no use. Okay. Having understood this one, now we will come back. Then what are the various relations? directions. Then my friends, do you not feel, because here we said that the spread, this one we don't consider, this one we don't consider, we are happy about this one or variance. The standard deviation is nothing but the square root of variance. Okay, no problem. Okay. Is there any some other way so that instead of this complicated thing, how it can be done? Because it will become more complicated. If the number of values are 3, okay, fine. If the number of values are 5 or 10 or 20 or something like that, what is going to happen? That is another thing. So that is why they started thinking, is it possible to estimate what are the easiest ways, and from those easiest ways, how to find out the required thing. Okay? That is what is being done under these control charts for variables. For that purpose, the spread or the deviation can be found out by using the one more thing. Not only these 3, 1, 2, 3, the fourth thing is the range. Range also gives the width of or the spread of the values. From what values to what value it varies. That is what it gives. Range is what? Range is nothing but the difference between the largest value and the smallest value in that group. Over. That is the range. Can we find out by finding out the range, is it possible to find out this universal standard deviation? They started thinking like that. Then the answer was yes. So many, because that is what Seward that he did, and he developed certain tables. They have been put under certain, lot of research work was carried out, and they have been put under some tabular form that will see it. Okay. Another important crux, what we need to do, or we have already studied about, what is central limit theorem. Central limit theorem, that is CLT. What exactly it means? What does it convey? What is central limit theorem? For that purpose, let us take some of the things. Okay. Let us consider some 20 values. Let us say that in general I have collected, because some process is going on, the single spindle automatic machine is there, and it is manufacturing, the shafts and the tools and everything have been set. So we are collecting the information because it is a repetitive process. Day in and out, same thing is produced. Then only it can be subjected for this control charts for variables or for control charts, not for the individual item. It cannot be set. It is for the group. Okay. When repetitive process is there or in mass production, that is what we discussed in yesterday's class. Okay, what this central I am talking about, in that case, let us say that we have collected 20 which are being manufactured, process is going on, I have collected. Let their values be x1, x2, x3, up to x20. Suppose if its intended diameter is 20 mm, then these values, they will fluctuate around those 20. Something will be 19 point something, or some of the values will be 20 itself, some of the values will be slightly greater than 20, like that. So there are 20 values. Okay. Then what is going to happen? We try to think. How I will find out the average? Average value I can find out, x bar values is equal to what? x1 plus x2 x20 divided by 20. This is called as x value, no doubt about it. And how do I find out the standard deviation? Standard deviation is found out by x1 minus x bar square plus x2 minus x bar square up to x20 minus x bar whole raised to square, its mean and its square root. This is what is to be done. Okay, then I will decide. What I will decide? I will try to compare with, or I will think that it follows the normal distribution. The another name for normal distribution is what? Gaussian distribution. All means the same. Gaussian or normal. It is bell-shaped. This is the characteristic. Bell-shaped. It is equally divided around its area. Central values, that means more frequencies or more values will be crowded around, and it will outside end. And they have also found out, because why I am telling is, yesterday we were talking about 3 sigma limit, 2 sigma limit or something like that, or 6 sigma limit. What is meant by that? It was observed that if this were the mean, mu, and if it were the standard deviation, okay, this side I can say that this is sigma away, sigma prime away from the, it is lesser than sigma prime from the mean. This is another sigma prime. That means this whole thing I can say mu plus or minus sigma prime. And I can take this as 2 sigma Is it understood? Now it has been found out that within this one, how many values are there totally? That means it constitutes, how much area it constitutes? It roughly constitutes around 68.45% of the area, or between mu prime plus or minus sigma prime, and roughly around 95%, 95.65, this is 65% of the area is between mu prime plus or minus 2 sigma prime, or 2 sigma, that is what we say, sigma, 2 sigma, 3 sigma distance from the, this is the spread from the mean, because always it is measured with respect to that mean only. And about 99.73% of the values in plus or minus 3 sigma prime. This is the crux. That is what we are. That means almost 100% of the values will be falling within mu plus or minus 3 sigma. Okay, that is what we need to understand. The whole crux of this. Okay, this is what is understood. If it follows the normal distribution, that means whatever the values I have taken, if they follow the normal distribution like this, then only it holds good. If it were the case, then many of the processes, if we understand, even though we say that it is normal or the natural, Gaussian or normal or natural, whatever it is we can call. naturally or mostly. But is it a rule? No. Many of the things might follow, they follow the normal distribution. The few or many of them, they may not follow. In that case, what is to be done then? First, we need to establish that these values, whatever I am collecting, they are coming from the normal distribution. Then only I can apply this one and say. So in that case, it will have the limited scope. Then what is the way out? They started thinking. They said, don't take the values like this. Because this is the power of that central limit theorem. It says, don't directly take like this. Then what is to be done? Instead of taking these 20 values directly, you make them into some groups. What is that he is telling? Because the central limit theorem, it says that the mean values always, irrespective from where this x1 to x2 value they come from, whether it is the normal distribution or it might be from triangular distribution, okay, or it might be triangular in this way or in this way, or it might be uniform distribution, or it might be some other distribution, exponential distribution, whatever it is you can think, or I don't know, it's a distribution itself. Irrespective of that, if we make them into some groups, the group should not consist not less than 5 values. Okay. 4 to 5 values, not less than, they say that not less than 3 values. I cannot consider only one as a one group and say that there are 20 groups. I cannot make it like that. 2 or 3. No, usually 5. Because it has got a special significance. Why most of the things we take the 5 as the sample. You might read the book and then try to find out how deducible it is, how easier it is to find out its mean if I take 5 values. If other than 5, it creates certain problem. Because that is why even the God has given us 5 fingers. Try to understand. Not 6, not 4, okay, not 3. So since we have got 5, will become more rigid or more systematic. Something whichever our grip is, very good. Okay, any variations can be accommodated. Anything can be, sizes can be accommodated in that. Okay, that means what it says, we will divide into some groups. That means what I will do, I will divide it into some 4 groups. Let me say x1, x2, x3, x4, x5, I will make as one group. And x6 to x10, x11 to x15, and x16 to x20. So, instead of these same 20 values, I have made 4 groups, each consisting of 5 values. This is what I say subgrouping. Try to understand. I have grouped same things. I have grouped into different things. Then which one is to be taken? Can I pick up random? Yes. But in control charts, these values are picked up not in random. It is in chronological order, chronological way. Because as per the time, whichever comes first, second, third, fourth, fifth. Okay, 5th sample I have taken this. 6th sample, whatever. Okay, then that is second group like that. Okay. So the chronologically I will collect them. That is the crux of that. Okay, there are 5 values here, 5 here, 5 here, 5 here. There are 4 subgroups. Each will consist of 5 values. That is subgroup size. Number of subgroups are 4. What is the size of each subgroup? Each subgroup will consist of 5 samples. That is what it means. So in general we say that N Sub. Here number of subgroups are 4 because this one you keep it in your mind. Because when we go towards the solving of the numerical problems or the numericals or establishing of the control charts, these things will become more vital. That is why I am explaining at this stage. This is sample size. Here it is 5. Subgroup size, the number of subgroups, it is denoted by M. So whatever the mean I find out for this, mean I will find out. Let me call it as 1, that means x1 bar. Okay. That means x1 plus x2 up to x5 divided by 5, I will call it as x1 bar. Similarly, this is x2 bar. x2 bar is what? Similarly, I can find out. That means how many values I have? I have what? 4 values, namely x2 bar, x3 bar, x4. Now try to understand the beauty of this. All this x1 to x20, they may come from normal distribution or they may not come from normal distribution. They can come from any type of distribution. But when I make a group of this and find their mean, these means whatever are there, always they will follow the normal distribution. Try to understand. So the mean values will always follow the normal distribution. That is what is dictated by central limit theorem. Okay? And inverse is what? Population inverse is what? One way is x1 up to x20, and instead of this one, that is why instead of saying x bar, they have said it x bar prime. Okay? Otherwise, don't get confused. Okay? x1 bar or x bar or x bar prime. Or I can say this is equal to all these 20 values I will take and their mean S. Instead of this one, I will part by part, I will find out this x1 bar and other things. Then again, things. That means x2 bar plus x. If it is not visible here, I will go here and then draw it. Now I will take x1 bar plus x2 bar plus x3 bar plus x4 bar divided by 4. Okay. In reality, what is this? It consists of 5 values, 5 values, 5 values, 5 values, and there this thing, because there are 4 means, I am getting this one. This is, I call it as x double bar. This is also equal to x bar prime, or which is equal to mu prime. No difference. You can directly find out this one by these things, or from this group. No difference at all. Well, why I have made it as a group? I know that this value, these means, they will form the normal distribution or they will follow the normal distribution. So there is a variation among these things, x1 bar, x2 bar, there is a variation like this, just like the variation between x1 and x2. But these variations or these things, distributions, because that is how it varies. It has to follow some distribution. Which distribution it follows? It follows the normal distribution. Hence we know everything about this normal distribution. Then we are in a position to predict it. Okay? That is why always they are going to have in different subgroups. That should give you why subgrouping. Why not individual values? This is the reason. If I take individual values, then the basic thing what I need to establish is, first I need to establish that it follows no normal distribution, otherwise I cannot go ahead with it. Okay, is it understood? Okay, this is x double bar or x bar prime and other things. Okay, that means this is the x double bar, that means what? This value is called x double bar, which is the best estimator of the universal mean, either mu bar or x bar prime. That is what we say. But what about the standard deviation? That means universal standard deviation I want to find out. How do I find out the inverse standard deviation, sigma prime? One way I have showed you like this. Find out. What is to be done? Okay, just started doing these things. Okay, that also I'll tell you, because these things are required. So for these samples, as I found out x1 bar, similarly I have to find out sigma 1 bar, sigma 2 bar, sigma 3 bar, and sigma 4 bar. This is what they started finding out. Okay, these things, because these variations or whatever are there, they are inevitable in nature. Okay, these things need to be found out. Or the other things I can think about is their variations of these things are going to vary, or we can find out variation of this x bar values only. This variation I can find out, which I name it as sigma x bar. Variations are there, is it not? Okay, sigma x bar is equal to 2. But there are so many ways of finding out this. So in this case, minus x double bar, or I'll write it here, sigma x bar is equal to x1 bar minus x double bar whole raised to square plus x2 bar whole raised to square plus x3 bar whole raised to square plus x4 bar whole raised to square divided by 4. This is called as sigma. As we have found out, just mean of this one is equal to x bar prime. If I find out like this, it may not count. You got this one? It is not, this sigma x bar is not equal to sigma prime. No. Whereas mean, yes. Here we can observe that this sigma x bar is equal to sigma prime by square root of n, where n is the sample size. These sizes 1, 2, 3, 4, 5, not this m. Okay, this n is, because it depends on that. The more this one, the more authenticity we have. Lesser this one, the variation is less. More this value, that's good. That is what we say. Okay, this is how it is to be sigma x bar can be found out. That means here when we are going to construct the control charts for variables, one chart we can construct for central tendency, which we call it as x bar chart. Why x bar chart? Why not x chart? X chart means individual values. We are not going to consider individual values. We are going to consider the group values. That is why the x bar chart. Okay, that x bar or x double bar value we are going to find out. And similarly, we are going to find out the sigma x bar variation. So how much variation I can allow? And if the process is between this variation plus or minus variation, that is what I told you, plus or minus variation. If it is within that, it is perfectly natural. If it is away from that, no, it is something assignable cause is there. That means what? For example, here, how do you interpret 99.73% of the values will fall within mean plus or minus 3 sigma limits? How do you interpret it? If I take 1000 readings like this, collect the samples, out of 1000, only 3 are expected to fall outside these limits. Even then, it is perfectly normal. Suppose if I take only a sample of 5, then how many should fall outside the control limit? None of them. But if one falls, no, out of 5, one is falling outside these limits. That means it is going to produce some 20% effective. That is what we conclude, which is the wrong thing. It may be wrong. Because that one, whatever we have got in that sample, even if I had collected some 1000 samples, still it might be one of those things. Okay, sometimes it will become erroneous. That is what we call it as type 1 error and similarly type 2 error like that. Okay, based on how we are going to draw the conclusion about that one. Okay, this will give you some small idea about that. Okay, have you understood? That means how you are going to find out and what are the relationships they have. They have got the relationship like this, sigma x bar. That means these are the deviations of the sample mean. These are called what? Sample means. X1, X2, X3, X4, these are samples. And we have done subgrouping. These sample means. And these sample means have the variations. I name it as sigma x. And the standard deviation of the first sample, just I found out, just like mean sigma 1 I can find out. How do I find out sigma 1 here? X1 minus X1 bar, like that, X5 minus X bar, X1 bar, whole raised to square, divided by 5, square root of this, it will give me sigma 1. Similarly, I can calculate sigma 2, sigma 3, sigma 4. And sigma bar is equal to sigma 1 plus sigma 2 plus sigma 3 plus sigma 4 divided by 4. Is it going to be equal to the universal standard deviation? Again, the question is no. Try to understand. They have found out. So they have got a particular relationship. What are those relationships? Now also I will try to give you. And maybe in the future class, in the next subsection classes, we can put them in the form of the table. That means the sigma prime, or they found out one factor, C3 is equal to sigma bar divided by sigma prime. By extensive research and whatever it is, see what he has found out the value of this C3, which will depend only on the sample size. Whether the sample size you are taking it as 4, 5, 6, 7, 8, 9, 10 like that.